Okay, so let's check the supply now. Can you see? So if you want to supply this electric motor, we are going to supply through these terminals. Terminal 1, terminal 2, terminal 3. So these are the supplies of this electric motor. So you can see that this electric motor has a 3-phase electric motor. It utilizes the 3-phase, which is red, yellow, blue, and blue. So that is that about the. Hope you understand. We were talking about a 3-phase electric motor and single-phase electric motor. A single-phase electric motor. Which kind of supply does it use? Yusuf, answer me, please. Which kind of supply?
Single phase.
Out of the 4 wires we have from the pole, which kind of supply does it use? Out of the 4 wires.
Red.
Alone?
No. Red, yellow, blue, and neutral.
So if I have a single phase electric motor, you mean I'm going to put in all the cables, red, yellow, blue, and neutral, all the 4 cables together? Then what do you mean? How am I going to do this? Ibrahim?
The single phase motor uses 1 phase, 1 neutral.
Exactly, thank you. So it chooses 1 phase, 1 neutral. It means it can either use the red phase with the neutral, which is this, to achieve a voltage range of like 200 to 220, or yellow phase and neutral, or blue phase and neutral. So it can only use 1 phase and 1 phase and 1 neutral. Whereas a 3-phase electric motor uses how many phases? How many? Jamin, it uses how many phases?
3 phase.
3 phase. With the neutral bar?
No.
So it uses a 3-phase. Either it's using the 3-phase supply, the red, yellow, and blue simultaneously at the same time without using the neutral. So that is that. No. So.
Mouse generator.
Post it. So whenever you are giving any electric motor to the one like this one now, so this one is a blunt electric motor. As you can see the damage on the motor. So the first thing you are going to check is the nameplate. This is the nameplate of an electric motor. You can zoom in the nameplate. Zoom to the nameplate. So this is the nameplate of the electric motor. The nameplate is a plate whereby you find the details about the electric motor. Different electric motors with different ratings and different specifications. So like this one, you want to check the specification of this induction motor. Firstly, we have the type, which is a AEEF AC from the manufacturer. We have the output. So the output, this is the power, this is the rating of the electric motor. It is being written 0.5
HP.
5 HP. Okay?
Yes.
0.5 HP. The power rating. Power rating 0.5
HP.
Do you know the meaning of this HP?
Horsepower.
Horsepower. So 0.5 horsepower. And we also have what? 0.37 kilowatts, which is conversion of this kilowatt to watt will be what?
30,000 watts.
Conversion of kilowatt to kilowatt to watt is what?
3,700.
So you are going to divide it by 1,000. So it's going to you are going to multiply it by 1,000. So which should be, if you should multiply 0.37 by 1,000, it should going to be 370 watts. 370 watts. But what is the relationship between this horsepower and watt? Horsepower and watt. 746. 746 watts is equal to 1 horsepower. So, do you have a calculator? Let's try to divide 746 divided by 2.
And the one.
746 watts by 2 is what? 700 divided by 2, that's 350, right? 46 divided by 2, that is 23. So 23 plus 350. It will be what? 373. 373 watts. You can see that it's close to this. So that's why it is 0.5 horsepower. So which is not up to 1. If it's 1 horsepower, 1 horsepower is equal to 746 watts. So if you want to get half horsepower, it will be 1 divided by 0. Half of this is 0, half of 1 is 0.5. So 0.5, 746 divided by 2 is 373. So don't be confused about this wattage and horsepower, because at times you see some electric motors where they are going to write only the horsepower rating, but not with the wattage or kilowatts rating. So you have to be sure about it. You have to know the conversion. So after the kilowatts, we have Walaikum Salam. So we have poles. How many poles? 4 poles. 4 poles, Abi.
Yes.
So this is one of the specification of the electric motor. We have 4 poles. We have this insulation. Insulation type is B. Rotor type is C. Then this is IP 44. IP
44.
IP. You don't even know this IP.
No.
Is ingress protection. Ingress protection. This ingress protection, the first value, one of these values is for against the protection against liquid, while the other one is the protection against dust. So there is an ingress protection table. So you can get the table and check the level of. I think the highest level of ingress protection is like IP maybe 6.5 or 6.7, something like that. So each number from 1, 2, 3, 4 of what liquid, and 1, 2, 3, 4, 5, 6 of a dust. So they have different type of level. I think IP65 is a dust tight and maybe deep sea or something like that. So since this one is 4, it just have little protection against dust and water, so it is not waterproof. This is not waterproof. So then followed by the arts. This art is arts. What does this arts mean? Thank you. Frequency. So the frequency of this the running frequency of this electric motor is 50 hertz. Then we have the volts of this electric motor 220 and 380. This 220 means if you want to power this electric motor with a single phase supply, there's a way you can power a 3-phase electric motor with a single phase supply. There's a way you can do that just for testing, not to carry load. So they are going to use a 220 supply. If it's 3-phase, you are using 380. So please, I forgot to mention something about this 3-phase. When I'm talking about 3-phase, I said phase to neutral. Shift back a little bit because of light. 3-phase, single phase, say phase and neutral should be within the range of 220 volts. How about phase to phase voltage? Phase to phase voltage. That is, I'm checking from red phase to yellow, red phase to blue,
Yes.
then yellow phase to blue. So the voltage should be within the range of 380 to 415 ideally. Though it can be more than 415 at times. If there is high voltage, it can be up to 420, 430 if there is high voltage. And if there is low voltage, it can be lower than 380. maybe 370, 355 or something like that. But ideally, it should be within range of 380 to 415 volts. That is what I'm talking about. Is that I'm setting my meter to voltage now in order to check the voltage of it of two-phase system or three-phase system. So I'm checking, put one probe in the red side, the red conductor, then on the yellow conductor I'm putting another probe. So the voltage I should see here should be within the range of 380 volts to 415 volts. So, but if I should check from either of the phases to neutral, it will be how many volts?
220.
So within range of 220. So face-to-face voltage should be like 380 volts to 415 volts. So that is why 380 volts is being written on this nameplate. On this nameplate. So 380 volts. So if I using the three-phase supply to power this electric motor, it should be face-to-face voltage will be 380. From this second phase to the third phase should be 380, while from this third phase to the first phase should be 380. So any voltage that is higher than this 380, maybe up to like 420, 425, is going to damage the electric motor. Hope you understand. So then amps, which is we have the amps, which is what? The current of this electric motor. The current of this electric motor. If you are using a single phase supply to power this electric motor, it's going to be, the current should be within range of 1.94 amps. But if it's on 3, you're using the 3 phase to power it, which is 380 volts, face to face voltage 380. The current should be within range of 1.12. So this is very, very important because whenever you are testing an electric motor for it, maybe the electric motor is in good state of operation, you will use this current to know if the motor is actually working well or is bad. So we have the RPM. Who knows the meaning of RPM? RPM is rotation per minute. Rotation per minute, RPM. So the RPM of this electric motor is 1,400. What the rotation per minute means is that, assuming you have the rotor of this motor is not here. Assuming this is the rotor that is inside the electric motor that rotates. Assuming this is the rotor. Assuming the rotor starts from here. This is the starting point. The time it's going to take for it to go from here back to the starting point. So it means for within 1 minute of rotation of this electric motor, it's going to do how many rotation? This rotor will rotate 1,400 times. 1,400 times. That is the rotation per minute. The rotor will rotate like a fan rotating. Start from a starting point. Assuming this is a fan. You have a fan, with how many blades? 3 blades, So this is the starting point. This fan starts from here. This blade, first blade, start from here, move here, make one circle. That is 1. So the time it takes within the number of rotation it makes within 1 minute. So that is what we call the RPM, rotation per minute. So this electric motor, if it's functioning very well, its rotation per minute should be within the range of 1,400 times. Then we also have the weight of the motor. Though it is not being written on the nameplate, which should be in kg. In kg. Then we also have the frame type 71. That is the frame structure. Then we have the rotor type C. Okay, we already talked about this one. We have this sign and this sign. So this sign we call it delta. What did I call it? Delta. What this other one we call it star. What did I call it? star. These are type of connections of electric motor. Electric motor can either be connected in delta or in star. We have delta connection and star connection. You can see this is a 3-phase motor, as we said earlier, which means it has 3 set of coils. 3
Set of coils.
3 set of coils. We have the phase 1 coil, phase 2 coil, and phase 3 coil. You can see from here, from the next page, you can zoom it. We have W2. We also have W1 here. That is 1 coil. We have V1, V2, that is another coil. We have the U1, U2, that is another coil. So the coil are being connected intervalvally to achieve either star connection or delta connection. So let's write this out. Let's say we have the W coil, we have the U coil, V coil, and W coil. So which will be phase 1, phase 2, phase 3. So, and each coil has a starting point and end point. Starting point and end. Assuming this is a coil now, we are starting from here. We want the coil. So this should be the start and this should be the end. So that's why we have U1, U2, W1, W2, V1, V2. So from this connection now, you can see we have W2 up, and down here we have U1. Here we have U2, we have V1, and we have V2, and we have what? W1. Hope you understand. So these are the terminals: U1, U2, V1, V2, W1, W2. So if you are connecting in delta connection, delta
connection.
Assuming this is delta. Delta is high speed. If you want the motor to be running on high speed, you connect in delta. If you want it to be running on low speed, you connect it in star. Low speed. You connect it in star. You also have the U2. So you want to connect it in delta. This is one terminal. This is the starting of first coil, the end of the first coil. Look at it. The starting of the second coil, the end of the second coil, the starting of the third coil, the end of the third coil. So you are connected in delta. It means you are going to link this one with a bar. This terminal, link them together. This terminal, link them together. This terminal, link them together. Then you bring out your supply from here: red, yellow, and blue. So this is how you are going to supply the electric motor. But if you are connecting in star connection, what you are going to do is that you are going to link all the end of the coil: U1, V1, U2, V2, and W2. You link them together. Then this down terminals of the starting of the 3 coils: U1, V1, and W1 is where you use to connect your supply: red, yellow, blue. So looking at this electric motor, is it being connected? These are the 6 wires, right? This is the W2, Abi?
Yes.
We have U1. You can see it's being written here. We have U1, and we also have here U2, V1, V2, and W1. So is this motor being connected in star or in delta?
Delta.
Why is it delta? Is it being connected in star or delta? Look at it very well.
Look at this star.
Is it star or delta?
Star. Star.
How do you know it is star?
Star.
How do you know it is star? Yusuf, don't block the camera. How do you know it is star? So you just follow the norms. How do you know it is star?
Because you connect the V2, U2, W2 together.
How do you know it is star?
Because the W2, U2 and V2 are connected together and the others are not connected.
Is it star or delta, Yusuf? It is star. It is star connection. This is the W2. This is the U2. This is the V2. They are being connected with this bar, being linked together. So if I want to change the electric motor to delta, I'm just going to untie this knot, or the 3 knots. Then I'm going to bring this bar, bring it here. Another bar, bring it here. Underneath this bar, there should be another bar. It should be 3 bars. Can you see it? Okay, you can see there is 3 bars. 1, 2, 3. So these bars are for the connection. You can remove one, place it straight. The second one, place it straight. The third one, place it straight. Then we'll supply the electric motor from here. So that's about that. So if you want to rewind an electric motor, these things are very, very important. This pole, because this pole determines the speed of the electric motor. We have different type of electric motors. We have 2 poles electric motor. We have 4 poles
electric motor.
We have 6 poles. We have 8 poles. We have 16 poles electric motor. It depends. So this pole is going to determine the speed of the electric motor. Assuming it is a 2-pole electric motor now, 2-pole electric motor, the speed will be within the range of 2,880 RPM. While this one will be in the range of 1,440 in some motors. In case of this one, it is being written as 1,400 RPM. In case of this pole, we can have this divided by 2 is what?
7.
7. So 700 RPM. So the higher the pole, the lower the speed. The higher the pole, the lower the speed. The lower the pole,
The higher the speed.
the higher the speed. In case of electric pump motors that is being used for pumping water and so, most pump motors are 2 poles. Being a single phase or 3 phase, they are 2 poles, because we need high speed in order to pull the pressure of water either from a well or from a borehole or from the stream. You understand? But this is just a fan motor. It's like a blower. Fan motor that's going to be, they use it to fan or what do you call it? Use it to fan a shake wrapping machine. This motor in particular is being used for a shake wrapping machine. Like these are most of those fans, most of them are 4 poles. But extractor fans, if you have seen an extractor fan before, the speed is not that high. It rotates slowly. So like the one I wanted, sometimes ago, some years back, is 16 poles. 16 poles. Because it doesn't require the speed to be as high as a normal fan. So that is that. About the nameplate of electric motor.
This one.